right, today we are just very briefly talking about some basic issues when we are working with word problems in an elementary school setting. I have a few examples here, but we're really not limited to these specific types of questions. It's more just giving us an opportunity to talk about word problems a little bit and things to think about as I might be teaching that. So let's look at the first one. They're not in increasing order of difficulty or anything like that. Let's move it up here to the top. There we go. Exercise 14:15. So let me set that up. Exercise 14:15, like so. Now, of course, in general, you really have to be aware of your audience, the student you're working with, and really tailor how you explain things, how fast you go, how slow you go to their needs. I can't guess that. It's really going to be a case-by-case basis, but at least this discussion can get us just thinking in the right way. Let's read it first. Jerry and Joel bought a large pizza. Jerry ate 1/3 of it, and Joel ate 2/5 of it. Then James came over and ate 3/4 of what was left. What part of the whole pizza did James eat? So very often, as it says in the little blurb here at the top as well, very often we are obsessed with the answer. And in a word problem, very often there are multiple pieces of information, and it's overwhelming to try and find the answer right away. And it's also, in my opinion, unreasonable to expect it of myself to know the answer right away. I read this, I want to know exactly what the answer is right away. No, more than that, I want to focus on finding a path, a journey to better understand the question. And that journey can lead me to the answer, to where I never have to worry about the answer. I am just trying to make sense of the question and trying to figure things out, better understand it, and then, hey, the answer might pop out at the end without me even really worrying about it. So let's say here Jerry. So often I just want to copy stuff down. Jerry ate, I forgot, what was it? 1/3 of the pizza. And then we have someone else also eating from the original pizza. Joel ate 2/5 of the pizza. Both of these fractions refer to the original pizza. So if the fractions are a little bit intimidating, we can very easily make it a bag of candy. Jerry ate a certain number of pieces from that bag. Joel ate a certain number of pieces from that bag. How much did they eat? Try and relate it to simpler numbers, but a similar situation, until they can realize, well, together, if I want to find out how much they ate, I need to add these together of the pizza in this case. Sorry, that H is a little messy. So I need to figure out how much did they eat all together so that I know how much is left of the pizza. So I'm not asking what is the question. I'm not asking what is the answer to this problem. That's never my question. I'm simply trying to understand what has happened and what information does that actually leave me with. So if they don't see the addition right away, well, let's get rid of the fractions and just make it integers while still capturing the essence of this information. So I want to add these together. So I could do that with a common denominator, depending on their level. I'm not going back to rectangles and going back to the very basics. When I layer a word problem on top, then the calculation should be done slightly more efficiently. So this will be 5 over 15, my common denominator, and 6 over 15, for a total of 11 fifteenths. So 11 fifteenths of the pizza is already eaten. It's gone. Let's emphasize here. Let's say, whoopsie, gone. So if a certain portion of the pizza is gone, how much is left? So it's really a series of questions I ask myself. How much of the pizza is left? I ask myself. Well, if they ate that much, then we can do it over here. 4 fifteenths are left. So it's me copying stuff down, me writing or asking myself a question. Well, if Jerry ate this much, Joel ate that much, how much of the pizza is gone? That leads me to having to add these numbers together. So then how much is left? Because James is going to come and eat from what's left. And I work my way through the situation. Then it says James came over and ate 3/4 of what was left. So this 3/4 now applies to what was left. So now I much better understand what James is doing. James ate 3/4 of 4 fifteenths. And I know the of keyword leads to the multiplication calculation. I can then easily do that with my shortcut as 3 fifteenths and simplify that if I want to. There's no need to simplify 3 fifteenths if you don't feel like it, but I can in this case to 1/5. So that means James, no, can I not write my James? Hold on. My tablet is a little laggy. If I go too fast, it needs to ask a question first. Hold on, what happened? Let me just look at this carefully. James ate 1/5 of the original pizza. And again, I could very easily rephrase this to not have fractions, but let's say a bag of candy. Jerry took some pieces, Joel took some pieces. How much do they have together? How many pieces are left? James then takes some pieces of what was left. So I can easily still capture the essence, but if the fractions are too much and they sort of distract me from the calculations I need and the questions I need to ask, I can simplify this. And notice how I forgot about what the question was asking. I'm just trying to figure out the situation. Now the question happens to ask, what part of the whole pizza did James eat? Oh, well, look at that. I already did that. In my process of figuring things out, I found that James ate 1/5 of the original pizza. Oh, that happens to have answered my question. So very often, by just exploring and trying to understand, put the pieces together that they give me, it leads me to the answer or something very close to the answer. I don't have to obsess about the answer up here. It'll distract me from what I have to do and make things much more complicated than they need to be. But if I just travel through the question, the journey takes me to the answer. It's a much less stressful way to think about these things. Now, did I write or did my laptop? There we go. Much less stressful, that if I just analyze the situation and carefully think it through, the answer will probably pop out, or I'll get very close to the answer and I could just make that final jump. These don't go up in complexity. 1416 might be easier, might be more difficult, who knows. 1416 says, how many germs 0.002 centimeters long would make a line 0.9 centimeters long? It's really a very simple question in essence. However, the presence of these maybe less familiar decimal numbers distracts many students from seeing what the calculation is. So we could change it and first ask maybe, laptop is just laggy. Come on, did I write my M? I think I did. Oh, no, I just did a random line. Okay. Come on, laptop. Come on, we're recording. You're letting me down here. Oh, that was sort of an M. Maybe, and again, you have to gauge your audience, right? Maybe ask, let's make it little wormies. Let's say a worm is 2 centimeters. Let's say a worm 2 centimeters long. That doesn't seem too long for a worm. How many worms can I fit in to, let's say, 90 centimeters? How many? It really doesn't matter what the numbers are. How many can fit in? Let's suppose I put 3 rulers together. That's 1 ruler. Let's make it a little longer. 90 centimeters. So I still have the essence of the question, but the numbers are far, far less intimidating and not distracting me from what I need to do. I can even draw a little picture. There's my line. That's 90 centimeters. 90 centimeters. I laid a little wormies. 2 at a time, 2 centimeters at a time are being used. Hopefully, they can make the connection that this is a division problem. So the calculation behind this to answer this will be 90 divided by 2. Now, unfortunately, it's an uphill battle sometimes. You realize that, the decimals are distracting them and they can't see that it's division. Okay, so let's change the numbers. Then when I change the numbers, I say, okay, well, let me ask you a different question first. Let's talk about worms. Let's ask this question first. Then many times the student would get upset and ask, well, I'm trying to do this question. This is my homework question. Now you're asking me a different question? That means I have to do 2 questions. What are you doing to me? Well, unfortunately, they won't see always that I'm trying to actually help. By asking a simpler question first, we can overlay the actual question on top of this and see that it's actually the same. So now let's make it some color here. Let's maybe make a little pink or purple. Now I don't have worms. I have small little germs instead. And I have, let's change the color even further. If my laptop will stop freezing, thank you. I have just 9 centimeters. Or we could just pause and wait for it to catch up. There we go. Is it caught up? I don't know. It's a little unhappy. So that means wherever I see, whatever I did, the question didn't change. Only the numbers changed, which means what I do in the question doesn't change. It's still a division question. However, I'm just instead of 90 using a 9. Still division, because none of the words changed. Instead of 2, I'm using 0.002. So the question is exactly the same, but I understood the division with simpler numbers. Then when the numbers get complicated, I can hopefully realize that nothing actually changed, and they were just a distraction. So now if I ask how many germs of this purple length can fit into this pink length, it's still the same calculation. But early on, they get very distracted by the weird numbers, making them feel as if, oh, I need to do something else because this is very different. These numbers are different, therefore everything's different. But by changing the numbers, we can hopefully see that it's not different, it's exactly the same. So now I can look at this in terms of thousands maybe, and remember that this is 9.000. So this is 9,000 1,000ths. And this is 2. Let's write that down. 2, 1, or let's not say 1 here. 2 thousandths. And this is 9,000 thousandths. So therefore, this is the same as 9,000 divided by 2, which is hopefully fairly easy as 4,500 or 4,500 thousandths. Now, again, I'm just picking a level that I'm guessing. You have to gauge your student, and they might need more, they might need less. Who knows, right? Sorry, that's not 1,000. I am just thinking of multiple things at the same time. Sorry. Scratch all that. Everything else was good. The laptop wants me to live my pain by not wanting me to erase that. Fine. I wrote thousands by accident everywhere. And of course, the division question has an answer that has a unit different from the original, right? Because the answer to a division question is how many times does it fit? How many times does it fit into whatever was given? So the answer is the little germs this long can fit into my pink length 4,500 times. Again, it has to be scalable, and the only way I can scale things successfully is by really understanding what I am doing, building it up with experience slowly over time. But if I can just barely do these questions, then I'm not very flexible to adapt how I say things to suit the needs or to fit the needs of the student. That's where things get a little shaky. All right, so let's go to 1417. We're halfway. Let's have a look. To prepare for a large gathering at church, you use a recipe that calls for 3/4 of a cup of milk. You have 1 quart of milk, that's 4 cups. How many full recipes can you make? Now, of course, with experience is the only deciding factor here, right? And you have to gauge, do they recognize that this is again a division problem? If not, you can translate it to using not fractions, using simpler numbers keeping the words and everything the same. It's a variety of ways you could do that. You could change it up completely. You can talk about bags of candy again, right? You can do whatever. Like I have a large bag of candy, let's say 40 pieces. Each child gets, what shall we say, 3 pieces. How many full children can you make? For example, right? And change it, keep it, make it simpler and simpler in the number, not in the words, until they realize the calculation behind it, and then transpose these quote unquote more difficult numbers on top. Nothing has changed. So it is just a matter of adapting to your audience. In this case, it's 4 cups divided by 3/4 of a cup, because I'm trying to see how many times does 3/4 fit into 4. That is exactly the intuitive division question. So then I can use my knowledge of how to shortcut fraction division, making that 4/1, making it multiplication, and then division by a fraction is multiplication by the reciprocal. I can write the next part over here. Then I multiply across 16/3. If I wanted to, I could make that an improper fraction as 5 1/3. And then it's just important to interpret that. People forget that very often, like my tablet does when it freezes up. I had 4 cups. I'm trying to fit in 3/4 of a cup. The answer is not cups. The answer is a number of times I can fit the second number into the first. So in terms of the words of the question, how many full recipes can I make? We can make 5 full recipes, and then a third of a recipe if I really want to, but based on how the question is phrased, they only want the full recipes. 5 full recipes. And again, like I said, that's the theme here for this topic, this little subtopic. You have to be adjustable. You have to scale the detail up or down depending on your audience. And that requires me to really understand the question and how to approach the questions so that I can do it in multiple ways. Last one is 14/18. So of course I can't present all of that. I guess some middle ground. You scale it up, you scale it down, depending on the grade, depending on the audience. It's really something you have to do in the moment. Engage what needs to be done and adapt on the fly. If you see confusion, you pull it back, add more detail. You see boredom, you push forward and do less detail. It's an adaptive process as you go. Okay, 14/18. For your vegetable garden, you plan to plant 5/12 of it in corn, 1/6 of it in different kinds of beans, and 1/12 in tomatoes. You will plant the remainder equally in eggplant, onions, and squash. What part of the garden will be planted in onions and squash? Now, I always read the question sentence, this last one with the question mark, with hesitancy. I almost don't want to read it because often as soon as I do, I obsess over it. I want to find this. Instead, very often, I don't read that last part. I read what's happening to the garden, what's my plan. I'll plant the remainder equally in eggplant, onions, and squash. Boom, done. Stop. Let's just understand this completely. And then, once we better understand this and laid it out in a way that makes sense to us, we can go and say, okay, now that I better understand this, what do they want? And you'll most of the time find it's quite straightforward to then answer the question. But I have to help myself. If I read too much, I obsess over that and don't do the setup well. It's like when I write an exam. When I get the exam initially, I page ahead and look through the questions. If I see a question I'm going to struggle with and don't know right away, I'm going to worry about that through the whole exam. It's better to not look, and I get there when I get there, and then I'll handle it. But not everyone is the same, of course. That's just me. So I have my garden. Let's draw a little picture. Why not? There's my garden. Very pretty garden. I want to plant 5/12 of it in corn. That's almost a half, right? 5/12 corn. I'm not using the picture to make any specific conclusions. I'm just taking my time, drawing something. Maybe that's a 1/6. I don't know. What was that? Tablet? No. Tablet. Stop it. We're so close to the end. I got a lot of things open here. I understand. You can do it. There we go. 1/6 of it in different kinds of beans. Okay, beans. Beans. And then 1/12 in tomatoes. I like it. Little tomato sliver. I can't write tomatoes in that little bit. Tomatoes. Then the rest, we'll see. The rest. And then the question is, well, I need to work with the rest of the garden. The natural question is, how much is left? How much is left? That is my actual question. How much is left of the garden? Well, I used 5/12. I used a 1/6. I used another 12. Clearly, I have to add them together to see what I've used in total. So I want to make a common denominator. 1/6 is 2/12, and another 1/12. That'll be 9/12. Nope, not 9, 8. I wanted it to be 9, but it's not. It is 8. Just for the convenience of 9. So that is, I've used all of that with, or for, corn, beans, tomatoes, so far, 8/12. Now, of course, I can simplify that, right? Divide both sides by 2 to get 4/6. Divide both sides by 2 again to get 2/3. So that's maybe nicer. Because there's nothing wrong with 8/12, absolutely. But because I'm going to use this number in some future calculation, it does make sense to perhaps clean it up as much as I can. So now what is left? To calculate what is left, oh no, I don't even need to calculate it, right? It's right there. I just take it away from one full garden. So we have 1/3 of the garden left. So this is 1/3. But notice how I have not answered the question. the question sentence is talking about something related, but not exactly what I'm talking about. But once I better understand what has been used in the garden, what's left, I'm now in a much better position to answer whatever question they might have. I might still need to do something, but I'm definitely setting myself up for success. That is the key. Now they say, okay, the remainder will be planted with equally eggplant, onions, and squash. So 3 types equally. What part of the garden will be planted in onions and squash? Well, let's just do them individually. And again, there's different ways to do this depending on the comfort level of the student, of the audience. Okay, so what was it? So equally, I need to split this up. We need to split this part of the garden equally into 3 parts. How do we do that? By way of division. Each part is how big? 1/3 divided by 3. That means, well, that is division by a fraction, if I want to see it like that, which is multiplication by the reciprocal, which is 1/9. So each part is 1/9 of the original garden. Put a circle around that. So 1/9 of the garden will go to eggplant, 1/9 of the garden will go to onions, 1/9 of the garden will go to squash, and they will all make up the rest, the leftover, the third of the garden. Then they ask the question, how much will be planted in onions and squash? So that means 2 of the 3. So onions and squash will take up 2 of those. 1/9 plus 1/9, which is 2/9 of the garden. But there's a lot of things happening here, making it very tricky for students, very tricky. And it's my belief that one main strategy, regardless of the specifics of the question, a good strategy to put the odds in my favor is to not worry about the answer too soon, but to lay things out, to go on a journey through the question, better understanding the question at every step. We're better understanding the question until eventually the answer is really just a formality. I understand the question so well by the end, you can ask me anything. It's just a formality to answer your specific question. But if I obsess about the answer that they are specifically asking for, I don't take the time to really explore and understand what this word problem, what the situation is about. And then it becomes much more complicated. So hopefully that helped you out a little bit. Really just taking some questions to start the discussion, to get you thinking about potential issues and how would you address those issues. Not specifically regarding fractions, not specifically regarding anything. Just to be aware of what I'm walking into when I'm working with word problems and common issues and what I could do to alleviate that. All right, hopefully that was helpful. Until next time.